All right, let's dive right in. Today, we're talking about a foundational and honestly an unsung hero of the Java world, Java Database Connectivity, or JDBC for short. It's the magic wand that lets your app talk to pretty much any database out there. And in doing so, it solves a really common and really expensive problem. So picture this. You've poured your heart and soul into building this amazing application. It runs like a dream on, let's say, a MySQL database. Then you get the call. The client loves it, but they want to run it on Postgres now, or Oracle, or SQL Server. Does your stomach just drop? Do you have to rip apart your entire data layer and start over from scratch? Well, this exact nightmare scenario is why JDBC was created in the first place. And the solution it offers is just so elegant. The best way to think about JDBC isn't as just some library, but as Java's very own universal translator for the many, many languages of databases. So what is it really? JDBC is a standard API. You can think of an API as a set of rules and promises. It gives your Java code one common language to speak. Different databases, they might all have their own little quirks and dialects, right? But JDBC steps in as the master interpreter. And this is a huge deal, because it means you can write your data logic one time and have it work across a whole bunch of different databases without changing your code. And here's how that magic actually works. Your application, your code, only ever talks to the standard JDBC API. That's it. Then you just plug in a specific JDBC driver for whatever database you're using. That driver is the specialist. It knows how to translate those standard JDBC calls into the native commands the database understands. The key here is that beautiful separation. Your code stays clean and completely independent of the database. Okay, so connecting is flexible. Problem solved, right? Well, not quite. That brings us to our next big hurdle, the actual cost of making that connection. You can think of it as a very, very expensive handshake. I mean, think about it like this. Imagine you had to make a long-distance phone call for every single sentence you wanted to say. You dial, you wait for the connection, you say one thing, you hang up. Then you do it all over again for the next sentence. It would be incredibly inefficient. It's the same thing in the database world. Opening a brand new connection for every single query is slow, and it just chews through your server's memory and CPU. For any app with more than a couple of users, this just won't fly. Your whole system will grind to a halt. But performance issues are one thing. There's an even bigger, scarier monster lurking in the shadows, and that's security. When we're sending commands to our database, we have to be absolutely certain we're not accidentally opening the front door to an attack. And the most famous villain in this story is, of course, SQL injection. Now, in JDBC, you basically have two choices for sending a query. There's the basic statement object, which is simple, but it's also really dangerous. If you just mash strings together with user input to build a query, you're asking for trouble. Then there's the hero of our story, the pre-prepared statement. It is specifically designed from the ground up to shut down this kind of attack. So what's its secret? It's right there on the screen. It's those question marks. Those placeholders are everything. With a pre-prepared statement, the structure of your SQL command, the template, gets sent to the database and compiled first. The database already knows the plan. Only after that do you send the user's data to fill in the blanks. Because of this, the database treats that input as pure data, never as code it should execute. It's a firewall that stops SQL injection dead in its tracks. Okay, so we've made our queries secure. That's a huge one. Now, let's get back to our performance problem, that expensive handshake. How do we solve it for good? Well, the professional-grade solution is something called connection pooling. A connection pool is just brilliant. Instead of making that expensive call every time, imagine you have a valet service with a fleet of cars already running and waiting. Your app doesn't have to start a new car. It just grabs the keys to one that's ready to go, uses it, and when it's done, it just hands the keys back. It doesn't scrap the car, it just returns it to the pool for the next person. And the benefits here are massive. Performance just skyrockets because you've cut out all that waiting time. But then that has a cascade effect, right? Better performance means you're using your resources more efficiently, which in turn means your app can scale to handle way more users without even breaking a sweat. It just becomes more reliable. For any serious, high-traffic application, this isn't just a nice-to-have, it is absolutely essential. Okay, let's put it all together. We've got our standard API for flexibility, our pre-prepared statement for rock-solid security, and connection pooling for incredible performance. Now let's see how they all work in harmony to do the 4 fundamental things every database application needs to do: create, read, update, and delete. Or, as you probably know it, CRUD. So let's follow a user. It all starts with create. A new user signs up. We use an insert statement. And of course, we're using a prepared statement. Those placeholders make sure that the user's name and email are treated as safe, simple data, making the whole process secure from the get-go. Next up, the user wants to see their profile. That's a read operation. We use a simple select statement to go and fetch that user's data. The information comes back, all neatly packaged, ready for our app to show it on the screen. But what if they need to change their email address? No problem. That's an update. We use a where clause to target that specific user, and we use placeholders for both the new email and the user's ID. This guarantees we're changing the right record and that we're doing it safely. And finally, if a user decides it's time to part ways, we perform a delete. And again, using a placeholder for that ID is so critical. It ensures we're surgically removing only the user we intend to, and not, accidentally wiping out the whole table. That would be a bad day. And there you have it, the complete CRUD workflow, powered by JDBC. So let's boil this all down. If you walk away with just 3 things, make it these. First, JDBC is your ticket to freedom, database independence. Write once, connect to many. Second, prepared statement is not optional. It's your non-negotiable shield for security. And third, connection pooling is your secret weapon for building apps that are blazingly fast and can handle real-world traffic. Ultimately, JDBC is the powerful, reliable engine that connects your Java applications to the entire world of data. It handles the translation, it handles the security, and it handles the performance for you. The only question left is, what are you going to build with it? Thanks for joining us.